everyone. So today we shall be looking at this technical coding interview question. Kids with the greatest number of candies. So it says that there are n kids with candies. So you are given an integer array candies where each element in the candy represent the number of candies the height kid has, and integer extra candy denoting the number of extra candies that you have. So you have to return a Boolean array of result of len n, where each element of that array is true if after giving the corresponding kids with all the extra candies, you have the greatest number of candies among all the kids, or else false. And we know that multiple kids can have the greatest number of candies. I think that's straightforward. Here we have the first one is 2, 2 plus 3, 5, and that's the greatest. 3, 3 plus 3, 6, that's greatest. 8 greatest. 4 is less than 5. So you turn for 6 is greatest, true. Same thing here, 5, true. 3 is less. 2 is less. 2 is less. 3 is less. Okay. Also, how do we approach this problem? The trick here is that if we start from the first kids here, we need to partition the array to slice the array so that we treat the remaining ones as where we want to compare the maximum with when we do the addition. So when we add 2 plus 3, that will give us 5. Then the current kid has 5. Then we want to take this separate and actually see if 5 is greater than or equals to the other one. When you get here, which is 3, this is 6, we want to split it into 2 and look at what is before and what is after. So we can actually split the array into 2, and we check the maximum in that. So let's go about it that way. So we're to return result. So we want to initialize our result to be equal to this empty array, and at the end we're going to return it result. So what we now do is we want to go through our array of candies. So for I in range of the length of the candies, okay, then what we do is we check for the first one. So we're going to partition it into 2. So we check if, but the problem we might have is we don't want to start checking an empty list. So like here now, our I will be 0. So we should just check the right part, not the left part. So we need to have a way of checking whether there's something in the list before we actually check. Okay, so let's slice. We're going to slice the list into 2 based on I. So let me say left array will be equals to the candies from the beginning but not including I, and our right array is going to be from the beginning. It's going to be from I plus 1, because we are not including I plus 1 up to the end. Or we might check the edge cases. So we split that into three then. So the first case will be, I think that's the best way to do it. The first case will be if I is equals to 0, then we know that we don't have left, we only have right. Okay, so we don't have the left, we only have the right part. We'll just calculate the current. So let's calculate the current kid. Current kid Candy will be equals to the extra candies plus the candies of that current kids. Okay, so if I equals to 0, we will now check if the current kid Candy, the current kid Candy is greater than or equals to the max of the rest. So here is where we just check the right part. So we need this now. We just check the max of the right side. If it is greater than or equals to that, we will append true to our result. Otherwise, we will append false to our result. We just append false. Okay, so that helps us to be able to avoid having to check the left part, since we know when I is 0, we only have the right part. Okay, then we'll go back to our outer loop. Else, elif, if I is equals to the length of our candies, that's the last part, minus 1. So I can store the size of the candy into an array so that I won't keep calling the length of candies every now and then. So we'll just have this size candy in here, and we also have in here if it's equals to size candy minus 1 excuse me, then we repeat the same thing, but this time around we're going to tweak this to be the left part. So this will be the left part if it's greater than or equals to the left part. So this is the left part, not including that. So we have this. Okay, so that will check the left part if it is greater than or equals to the left part. Else excuse me, we check both parts. That's the final else. If same thing, we need this same thing here. If it's greater than or equals to the max of candies, or and sorry, that should be and it's also greater than or equals to the right part. Is the right part, so consider both cases. Then we append to else. So we are done with this. We don't need this anymore. So that's all. So we have three cases. First case is when I is 0. We handle that to just check the right part because there's nothing on the left. The second case is when I is at the end, the last element here, which is the length. This is 5 minus 1, so the index will be 4. 0, 1, 2, 3, 4. So when it is 4, so we just check the left part, not including the 4. Then every other thing, we check both sides must be greater than or equals to this and greater than or equals to, is this correct? Yeah, yes, on both sides. Yeah, so it should be hand. So that's it. So let's just quickly do a dry walkthrough, and we just do a small one because of our time. So let's do this. So what is the length of our candies? It is 3. So this one is empty at this time. So I becomes 0. So 0 is candy. So we had 3. Okay, this one is 10. 10 plus 12. So we have 22. So current. I equals to 0. So this is what we do. So we look at 22. Is it greater than or equals to? So this will be 1. So from here up to the end, is it greater than or equal to? Yes. So this appends true here. Yeah, which is correct. Then I comes to 1. Then here this is not the case. So this is not the case. This is not the case. So we come to this case. So this is 1. So what is the maximum for that? This is 1 plus 10. This gives us 11. So then 11, is it greater than or equal to? Okay, this is 1, so it doesn't include 1. No, it's not greater than this. What about the other part? This is 12, so this gives us 12. Is it greater than? No, so it will append false. So we have false here. And the last one, high is 2 now. So the extra kind term, this will give us 22. In this case, it is this case because the size is 3, 3 minus 1, 2, 2, 2. So we check the left part. So it will not include 2. So it's 0 and 1. So it's 22 greater. So that is true. Okay, so that works. What's that space and time complexity? The space and time complexity is just complexity. Space is big O of n because we have to create an extra result. Time complexity is also big O of n because we have to walk through the entire array, the entire candies just once. So let's run that. That works. So let's run the other one. This one. And let's see the last one. So that also works. So the last one. Okay, that works. So let's submit. Great, that works. All right, thank you and see you in the next one.